Hi, let's go to example 7, shall we? Now I've put a blank board this time because I want to show you how I draw my force diagram. Okay, so it gives you an idea of how you should be drawing yours as well. All right, so example 7, okay, it's on page 137. A non-uniform rod, very important of course if it's non-uniform. AB is 3 meters long and has weight 20 newtons. Okay, so let's just draw that in, shall we? So here's, for the moment, all we can do is just draw in the rod AB, and that's it for the moment. Okay. It rests on supports at points C and D, where AC is 1 meter. So I can put that. So that's C, and that's 1 meter, there to there. And D, it doesn't have to be to scale. I believe it says AD is 2.5 meters. The whole thing is 3 meters, so that's 0.5 meters. Yeah. Now, as soon as I put those supports in, what's a good idea to put in as forces? Yeah, normal reactions. Okay. So I'm going to put them there and there. Okay. Right. Question for you. Pause the video if you want. Will those normal reactions be equal? What's your answer? Okay. Not necessarily. Not necessarily, okay? It depends on where the weights are placed here, doesn't it? Okay? Depends on where these weights are placed. If the only weight acting on it, okay, is that there, right in the middle of C and D, then yes, they're going to be equal. Okay? If that's the only force acting downwards, and if it's right in the middle, then yes, they'll be equal. Try and think about why that is. Okay? However, if the weight acting on it is somewhere there, okay, then they're not going to be equal. Okay, they're not going to be equal. Here's how I like to imagine a scenario. Imagine you've got 2 people crouching down. Okay, person C and person D. 2 people are crouching down, and you've got the plank of wood that's resting on them. Okay, you're going to feel that, aren't you? You're going to feel that. Now imagine that the centre of mass was there. Okay, that means person C is going to feel more of the weight, aren't they? Yeah. Or, if that doesn't help you, okay, imagine that someone is standing there. Ooh, isn't that fun? Okay, sounds like some sort of, yeah, punishment that someone would actually give in class. Okay. Anyway, yeah, suppose you've got 2 people crouching down and a plank of wood is resting on those, and then someone stands there. Ooh, who's going to feel that more? Person C or person D? Yeah, exactly, person C. So you can see why the normal reactions are going to be different. Okay, so that's kind of little analogy there for you. All right. So yeah, when you've got 2 normal reactions, don't automatically assume that they are the same. Okay. In fact, it says the magnitude of the reaction at C is 3 times the magnitude of the reaction at D. Okay. So if you label the reaction of D as being R, we know that that there has got to be 3R. Okay. Hope that makes sense to you. All right. We're going to find the distance of the centre of mass of the rod from A. So that's the whole thing, okay? Right, so I'm going to put in the weight bit, okay? The weight was 20 newtons. Where's that going to go? Where's that weight going to go? Okay. I'm hoping that you find it obvious that the weight is there, isn't it? Okay. Somewhere there, okay? It doesn't matter where you put it, okay? But it's going to be somewhere in there, okay? Is it going to be closer to C or closer to D? That's another question for you to think about, okay? But it's going to be somewhere in between C and D, isn't it? Okay. And once again, hey, I can hear the cheers already. So here's my supports. Okay. Can you see I'm doing it so that the centre of mass is in between them? If I put my supports, I'm going to have to be quick at this. If I put my supports both under the lightsaber bit, whoa, see? Look, I'm gripping this. See what I'm doing there? I'm gripping. When I just let it go, see? When the centre of mass is not in the middle of the supports, the whole thing tilts. Even if I put it, look, it's going to tilt even more now because I moved this further. Well, if I move this one closer towards the centre of mass, it tilts less. But then if I put it at the centre of mass, put it there, can you see? If I just hold it like that, it's not actually tilting at all. Okay. But then, like I say again, whoa, yeah. So yeah, I imagine that the people doing the lightsaber fights, when they use the lightsaber, I imagine they're going to know exactly where the centre mass is, so it actually, I've chopped my hand off. I can't do that. I'd love to be able to do what Ewan McGregor does. He does this wonderful, I can't do that. Okay, I'd love to be able to spend a few hours of my life practicing what Ewan McGregor does, because what he does is fantastic. Anyway, enough of that. Okay, enough of that. It was exciting, wasn't it? It was exciting. Yeah. Right. And I can do it because this is about the force. Yeah, this is about the force. Okay. I always got my Darth Vader stand up. He's actually behind me. He's looking at me. Okay. Yeah. Maybe I'll show you afterwards because you'll probably think no, it's not. Oh well, at the end I'll turn the camera around so you can see Darth Vader looking at me. He's watching over proceedings. Okay. Am I doing well? Yeah, he's not happy. Yeah. Abuse of his lightsaber. Right. Anyway, let's continue then. So what we're going to do? Find the centre of mass. Okay. Well, yeah. As I said before, it's a good idea to take moments about A, the far left, and just call that distance x, and to work out what that is. Okay. Can you find what r is straight away? I think you can. So you've got 3r plus r, 4r must be 20 newtons. Okay. So r must be 5 newtons. Okay. I'm just reading the question again because I always feel paranoid that I've not put any more bits in there. There's not someone sitting there or whatever that I've not included. Okay. So I've just said that r is equal to 5, haven't I? So 4r equals 20, so r is equal to 5. So what that means is that this one, 3r, must be 15. Yeah? Happy with that? Right, good. And then you're away to go. Then we are away to go. Okay, so let's just do that. Please, can you always, in your working, write down a note of where you're taking moments from. Okay? You're going to be doing this next year in M2. Okay, as I've mentioned in a previous video, there's a lot of this stuff again in M2. So yeah, the work we're doing now is really crucial for next year as well. So it's important you get all of this absolutely right. Okay, so moments from A. So let's go from left to right. The first force we come across is that. Okay, I'm usually in the habit of writing down the first force I come across as being a positive one. Okay, it's just my own habit. So 15 times by 1, remember force times perpendicular distance. And then subtract, because it's in the opposite direction, of course. 20 multiplied by, and I've called that distance x, haven't I? Okay. And then next one, this one, which is the same direction as that, so it's going to be positive, and that's going to be 5 multiplied by, I really should have written that in, shouldn't I? Can you remember what I can't remember what the distance is of the whole thing. Okay, it's 3 metres long, so that's got to be 2.5. Okay, 2.5. Yeah, there we go. And all that is an equilibrium, so it's equal to 0. It's equal to 0. These questions, they're easy. They're really easy. Okay, they're really easy because, you know, it's horizontal plank. You've got everything that is either horizontal or vertical, perpendicular to each other. You can't get simpler questions than these, really. Okay. Right, let's work out what this is then. So that's going to be 15. Yeah. That's going to be 20. Let's put that on the other side, shall we? That's going to be 5 times 2.5. It's actually what, 12.5? And that's equal to 20x. So you have 20x is equal to what, 27.5? Yeah. And then x is equal to, what's that going to be? 27.5 divided by 2. 13.75, and then divide by 10. 1.375. Anyway, let's just try it. So 27.5 divided by 20. There we go. Yeah, that's what I thought, but it's always best to check, especially when I'm doing a video. The last thing I want is to write down the wrong number and have to do everything again, because it kind of looks a bit dodgy if I just write the wrong answer and then suddenly either send it out or re-record, because it kind of looks obvious. Okay, and remember what I said in the last video, always give a point of reference. 1.375 metres from A. Okay. One of the things to know about this question has out is different. There's no use of G. Did you notice that? No use of G. Look out for that. Look out for that. So sometimes it gives you a weight in newtons, in which case don't ever times that by G because that's incorrect. The weight is the weight. But when it gives you a mass, then you multiply it by G. Okay, so just look out for the differences there. Okay. I'll see they've rounded it to 3 significant figures. So you can do, yeah, 1.3 or even 1.4 will do, but that's fine. Okay. Yeah. So yeah, that's it. You're going to work through exercise 8D now. Hope you'll have some fun. And just to show you that I was not lying. Woohoo! And there we go. See, he's just looking out for me. There he is. Okay. Bye bye.